Okay, if you're following along in class, then what we've most recently done, is we've used a left-hand Riemann sum to estimate an integral of f(x) dx from 1 to 7, with the table as is shown again here. So we're going to do the same problem, but this time with a right-hand Riemann sum. So again, pay careful attention to the C column to see how this differs. And that's really the only difference. The difference in the C column is really the only difference in this question. So it's a Riemann sum. So it's going to be a 5-column table that we're going to make ourselves. So we're going to start off with the interval. And then the width. And then we're going to have C, and this time it's going to be a right-hand Riemann sum. Okay. So that column is where the big change is going to be. Then f of C. And then finally the width, which you can shorten to W, times f of C. Okay. So the intervals are the same as before. So the intervals are the x's. So from 1 to 2, from 2 to 4, and from 4 to 7. Okay, just lengthen those legs a little bit. Okay, so from 1 to 2, the width is 1. From 2 to 4, the width is 2. From 4 to 7, that width is 3. Now this is where the change is in column C. So in column C, we're using the right hand. It's a right-hand Riemann sum. So what we do is we look at the right hand of each of the intervals. So the number that we're going to put in here, the value that we're going to put in here into this third column, is going to be whatever is on the right-hand side of the intervals. So it's going to be 2, 4, and 7. So 2, 4, and 7. And now these are the values that we look up in the table. F of C, remember, means look up a value in the table. So the first one is, if x is 2, what's f of x? So look that up in the table. When x is 2, f of x is 15. Okay, don't let the C put you off. These are just particular values of x. When x is 4, f of x is 18. And when x is 7, f of x is 20. Now you'll remember that when we did the left-hand sum, we ended up not using this data point at 7, 20 at all. Now when we do the right-hand sum, we didn't use the data point 110 at all. Okay, so that's just one of the things that happens. That's a consequence of using Riemann sums. Okay, so we have width times f of C. So it's going to be 1 times 15 is 15. And we're going to have 2 times 18, which is 36. And 3 times 20, which is 60. Now we add these together. 6 and 5 is 11, 1 6 is 7, and 3 is 10, and 1 is 11. So we have the integral from 1 to 7 of f of x dx is approximately equal to 111. Now remember, when we did this previously with a left-hand Riemann sum, we got an answer of 94. So one of the questions you'd ask yourself is which of these is a better integral? And to be perfectly honest, we just don't know. Okay, we don't know which is the better integral. All we can do is work with the data we have, and we can look at the different estimates that we can get. So it can be anything from 94 to 111. They may not even be the maximum and minimum values. And the true value might be outside that, but all we're trying to do here is get an estimate. So, and we're not trying to say which is the better estimate. Okay, so that's our right-hand Riemann sum, and next we're going to look at a midpoint Riemann sum.